Welcome to your first flipped lesson. This is lesson 11.1, and this chapter deals with relations and functions. So first I'm going to define what the difference is between a relation and a function. Now before this chapter, we've translated verbal sentences into algebraic models. If they say, for example, the sum of x and a number 5 is 8, then you would make that x plus 5 equals 8. Well, now we're going to use tables to actually represent functions. And we always do these problems so that we can figure out answers to real-world problems. Okay, so here's some vocabulary, and you should be taking notes just like you would if you were in class. So a relation is a set of ordered pairs that relates an input to an output. A relation can be written as a set of ordered pairs or by using an input-output table. So a set of ordered pairs, remember, we have x comma y, or in this case input comma output. So here is an example. Input we have in blue, output we have in red. So here it is as an example of ordered pairs, and here it is as an example of a table. The input, the output. The input are commonly our x's, our x variables, and the outputs are generally the y variables. So a relation is a set of ordered pairs that relates an input to an output. So this is a relation. It's relating 2 to 5, 4 to 7, -1 to 15, and 0 to 0. A relation is only a function if for each input there's exactly one output. So every input has to have only one output. So the number 2 can't be outputted to 5 and be outputted to another number. It can only be outputted to 5 up here. In a function, you can say that the output is a function of the input. So 5 is a function of 2, 7 is a function of 4, etc. Here they want to know whether each relation is a function, and then they want us to explain it. So here I always look to see, do my inputs repeat at all? And if my inputs don't repeat at all, then every input has exactly one output. So yes, each input has exactly one output. That would be our answer. Now here the 9's repeat. This 9 is with a 3 and this one is with a -3. And if that wasn't bad enough, the 25's repeat with different outputs. So no, 9 has two different outputs. You could also say 25 has two different outputs, but you've taken care of it with the 9, so it's a no. Okay, here I have -2, 4, but I have another -2 down here. So -2 goes with 4 here, -2 goes with -4 here. So again, the answer is no. -2 has two different outputs. And here I have -4, 8, 0, 0, 4, 8, and 8, 32. It doesn't matter that this 8 is repeating twice. You can have outputs repeat for everything as long as the inputs each go to their own output. So 4 is only going to 8, 4 is not going anywhere else. -4 is only going to 8, but -4 isn't going anywhere else. So yes, each input has exactly one output. All right. Next, we have more definitions, domain and range. The domain of a function, not a relation, but just a function, is the set of all possible input values. So the domain hooks up with the inputs. It's like the x values. And the range of a function is the set of all possible outputs. So range goes with outputs, and those are the y's. A function rule assigns each number in the domain to exactly one number in the range. So again, because domain is input, range is output, everyone in the input has to have exactly one output, and that's what our function rule does. It's just an equation like we have down here. An online company sells puzzles for $5 each, and there's a shipping fee of $10. Here's the function they give us. C for cost equals $5 per puzzle plus $10 shipping. They want us to find the range if our puzzles are 5, 10, and 15. So I'm going to make an input-output table. So input, output. I'm inputting the number of puzzles. So 5, 10, and 15. My output comes from the function. So I go 5 times, I have 5 for my P, plus 10. Well, 5 times 5 is 25 plus 10 is 35. I'll do the same thing here. 5 times 10 from the input plus 10. 5 times 10 is 50 plus 10 is 60. And finally, 5 times 15 plus 10. 5 times 15 is 75 plus 10 is 85. So it says find the range. So my range is just 35, 60, and 85. So if I buy 5 puzzles, it's $35. 10 puzzles, $60. 15 puzzles, $85. For all these inputs, these are my outputs according to my function rule. How many puzzles can you buy for $60? $60, 10 puzzles. So that's how you're going to use an input-output table if they give you the function. Sometimes they're going to give you a table and you have to backtrack and find the function. For example, it says write a function rule that relates x and y. So they'll give you an input-output table, and our function rule, so make sure you write this down, y equals ax plus b. Now you have to understand how to find the a and the b. The x and the y are going to stay standard in the equation. Those deal with the input and the output. So to find the a, it's the change in the output divided by the change in the input. So change in the output divided by change in the input. So what we do now is we come over here and we see, well, what do these inputs change by? -2 goes to a -1, so it looks like we added 1. -1 goes to 0, it looks like we added 1. 0 to 1 we add 1, and 1 to 2 we add 1. So it looks like the change in my input is 1. So change in the input is 1. Change in the output, -5 to -3 bumps up 2. -3 to -1 bumps up 2. -1 to 1 bumps up 2. And 1 to 3 is 2. So the change in the output is 2. So now I have my fraction. So a is 2 over 1, which just equals 2. So I know that my a is 2. So far I have y equals 2x plus b. I still have to figure out the value of b. To figure out the value of b, choose one input output. pair. So I can choose any of these combinations. I'm going to choose 0, -1. The reason I choose 0, -1 is because I always try to choose anything with a 0 because it makes the math go pretty quickly. So I'm going to put this in for the x and for the y. X input, y output. I'm going to put it right into this equation up here. So I'll write it over here where there's a little more room. So y now is -1 equals 2 times the x is 0 plus the b. I'm left with one variable, so I'm good to go. -1 equals 2 times 0 is 0 plus b is b. So b is -1. So my final equation, I'll write it up here to the top, y equals a is 2, x, b is -1. So there's my final equation, y equals 2x minus 1. And if I were to check any of these points, -2 times 2 is -4, minus 1 is -5. Positive 2 times 2 is 4, minus 1 is 3. All the other points in between would change. Let's do another one of these examples. So I know y equals ax plus b, and I need to find my a. It's the change in the output over the change in the input. I'm just going to call those O and I. My input looks like it changes everything by +1. My output is changing also by +1. So this one's pretty easy. I've got a 1 over 1, so a just equals 1. Now I have to choose, well, first of all, I guess I have y equals 1x plus b. Now I'm going to choose a point. I don't have 0 to choose from, so I'll just do 1, -7. Again, remember, this is your x, this is your y. So I have -7 equals 1 times 1 plus b. So -7 equals 1 plus b. Subtract the 1. -7 minus 1 is -8 equals b. Now I have both parts. I have a and b. So my final function is y equals 1x minus 8. And you can check it with any of these. 1 minus 8 is -7. 2 minus 8 is -6. 3 minus 8 is -5, etc. So that's how you're going to go ahead and write a function. I'm going to stop this video now and start up another one because if I go longer than 10 minutes, YouTube will not let me post. So there's part 1. Don't